Right. Okay, guys, today we are going to discuss some questions in the unit and dimensions field, uh, which is not discussed during the class time, right? So let's start with the 16 questions, right? So in the 16 questions in the tude, a certain characteristic of an equation is shown in the following, where A and where A and B are constant and R is the universal constant, obtain the dimensions of A, right? So in this question, so if I write the equation, that is P equal AB squared into B equal RT, right? So in this equation, P, V and T are given, that is pressure, volume and the temperature, right? So now we want to obtain the dimensions of A, right? So if you want dimensions of A, now A is mentioned in this inside this bracket, right? So I have told you that if there's a bracket, the dimensions of the each term inside the bracket should be equal, isn't it? Right. So in this bracket, there we can able to find out that there are two terms inside this bracket. So what are the two terms? That is P and the A over B squared, right? So according to the theoretical things, the dimensions of P should be equal to dimensions of A over B squared, right? Then if I subject the A over B, if I subject the A, then I can able to obtain that P B squared, right? So now we have to obtain the dimensions of A. Now the thing is, we have to substitute the relevant dimensions for this equation. Now P represent the pressure, so the dimensions of pressure should be equal to M L minus 1 T minus 2 into V. Guys, keep in mind that dimensions of P should be equal to L cube, right? But here they consider the P squared. That means you have to substitute L cube into the power of 2. That means this should be written as L into the power of 6. So the dimensions of A should be M L5 T minus 2, right? So this is the dimensions of A, right? Right. So let's move on to the 18th, in the 17th question. In the 17th question, for the force required to separate a disk of area A from a solid is given as follow. That is F equal 2A G dt into the power of x. Find the value of x used by using the dimensions analyzing method. Now T represents the surface tension, D density, G is gravitational acceleration, right? Okay. Now A mean area, isn't it? Right. So if I substitute the relevant dimensions, now F mean force, no? So it should be ML T minus 2. So when you consider about the dimension, you can able to neglect the numerical values, right? So A mean L squared, then G mean L T into the power of minus 2. D mean density, so the dimensions of density equal ml minus 3 into T means surface T means surface tension. Guys, you might remember that the dimensions of surface tension Now, surface tension can be obtained by using this equation, right? That is F over L, right? So F mean MLT minus 2 over L mean, now L here, L represent the length. So the dimensions of surface tension is MT minus 2, right? So normally, we are not familiar with the dimensions of surface tension, right? So so it's better to keep in mind this equation, right? Because surface tension can be obtained by force dividing the length, right? So this should be the dimensions of surface tension. So we substitute this, right, into the power of x, right? So now we are going to analyze the dimensions. Let's starting with the m, right? So if we consider the m, in the left side, the index of the m is equal to 1. So in the right side, guys, I will further simplify these dimensions, right, inside the bracket. Then it should be m squared L into the power of minus 2 T minus O x, right? So let's start analyzing the dimensions starting from m. In the right side, the index should be equal to 1. In the left side, it should be 2x, isn't it? So now we have to obtain a value for x. Then x should be equal to half, isn't it? Right? So now in the question itself mentioned that obtain the x value by dimension analyzing method, right? So it is just a simple thing, right? Okay. Now raise your hand if you obtain this answer, guys.
Recording in progress.
Now hands up who's obtained this answer, guys. Right, very good. Right. Good. Right. Okay. Now let's move on to the other question. So in the 19th question, the equation that shows the relationship between distance traveled by the vehicle, that is x, and the time t, you have to find the dimensions of a and b, right? So this is the equation a b squared into bt over 2 plus 1, right? Now we have to find out the dimensions of this given equation a and b, right? So first of all, I think it's better to expand this equation, isn't it? Oh, so one method is just expand this equation, that is multiply AT squared from the two terms which is inside the bracket, right? So that's a one method. Or you can able to consider that this is a second method, right? So if I bring the AT squared into the opposite side, so it's come as a division, isn't it? So it is equal to BT over 2 plus 1, right? So by looking at the equation, you can be able to figure out that now in this equation, it is consists of three terms, isn't it? This is the first one, this is the second, and this is the third one, right? So accordingly, S over the dimensions of S over AT squared should be equal to dimensions of BT over 2, and it should be equal dimensions of 1, right? So let's consider these two, that is x e s over AT squared equal to 1. So now we have to obtain we need to obtain the dimensions of A. So if I subject the A, then it is equal to x over t squared, right? S represent the displacement and t mean time. So the dimensions of A should be equal to LP minus 2. That is the dimensions of A. In order to obtain the B, let's consider these two terms, right? So here, T mean time, no? So the dimensions of time should be capital T equal to 1. You can neglect the numerical values, right? So the finally you can able to obtain that B dimensions of B equal to T minus 1. Right? Right. Let's move to the other question. In the 20th question, the relationship among the physical variables x, y, z are shown in by the equation. Here time is measured by the second. So this is the equation x equal yt plus k z t squared. K is a unitless constant and unit of y is ms minus 1. Find the units of z, right? So here, now if this equation is correct, you know that in unit wise, if we consider the unit wise, the unit of x should be equal to unit of yt, and it should be equal to units of k z t squared, right? So the thing is you have to find the units of z, right? So let's consider two terms. So I'm go for the so this let's consider these two, right? So if it is, then the units of yt should be equal to k z t squared, right? So you can able to neglect the k because it's a unitless constant. You can able to neglect the k, and if I further simplify the t, then y equal zt. So if I subject to z, then it can be you will able to obtain that y over t. So they have given the units of y, that is ms minus 1 over t mean time. So it should be seconds. So the units of z should be equal to mx minus 2. Right? Okay. In the 21st question, velocity v given by the equation Vy equal k a into the power x, where x also represent the displacement, where x and y are integers. X and y are integers. What are the possible values for y and x by considering the dimensions of the equation, right? So guys, now we have to consider the dimensions of these equations, right? So according to the dimensions, if this equation is an accurate one, the dimensions should be left side should be equal to the dimensions of the right side, isn't it? That's a theory, right? So let's go for the dimensions now. V mean velocity, right? So it should be LT minus 1 into the power of y. Uh, Now, guys, just write a. I think there's a small mistake in these questions, right? So the question should be mentioned that k is a dimensionless quantity, right? Just write it down. Just mention the intuitive, that is that k is a dimensionless constant, right? There's a small mistake in these questions, right? So that's why you can't able to obtain the correct answer, right? So here, now k is a dimensionless constant. That means we don't need to worry about the k in when obtaining the dimensions, right? So x a should be uh, Guys, there's another issue in this equation, right? So there are two mistakes in this question. The first one is k is a dimensionless constant, and a should be simple. A should be defined as the acceleration, right? A should be defined as the acceleration. So those are the two mistakes in these questions, right? We can able to neglect the k when if the a is the acceleration, so it should be lt minus 2 into the power of x, and l they have x defined x, that is displacement, so it should be l, right? So according to the theoretical things that we learn, let's go for the dimension analyzing. So let's start with l. It should be y equal x plus 1. So let's consider this one as a plus t equation. Let's go for the t. Then minus y should be equal to minus 2x. So guys, that's mean if I divide the both sides from the minus 1, so it should be y equal 2x, right? So let's substitute the obtained value for the first equation. Then it should be considered as 2x equal x plus y plus 1. That's mean x should be equal to 1. Hence, y should be equal to 2. Right? So this is the answer. Right. So then let's move on to the next one. That is 22nd question. The Van der Waals equation of state for some gases can be expressed as P plus A over V squared V minus D equal nRT. So this is the guide. This is the Van der Waals equation, right? You don't need to worry about this equation, right? So where P is the pressure, V is the molar volume, and T is the absolute temperature of the given sample of gas, and A, B, and R are constant, right? So you have to find the dimensions of A, B, and product of A, B, right? So in order to obtain the A, right? So you should notice that there's a two brackets inside the equation. So if this is a accurate equation, so it should be dimensions of P should be equal to dimensions of A over B squared. Then A should be equal to P V squared. So in order to obtain the dimensions of A, let's substitute the relevant dimension for these equations, right? So here P mean pressure, that's mean ml minus 1 P minus 2. Now V mean volume. So now dimensions of volume should be equal to L cube, isn't it? So we have to consider the square, right? So then it should be 6. Then the answer should be this is the dimensions of A, right? So in order to obtain the dimensions of B, let's consider this bracket. So inside this bracket, there are two terms, isn't it? That is B and B. So according to the theoretical for things, the dimensions of B should be equal dimensions of B. Hence, B mean volume. So the dimensions of L should be dimensions of B should be equal to L cube, right? Okay. Guys, just raise your hand if you obtain the answer. right? So in the 23rd question, in the following statement, I and V denotes current and voltage respectively. C is a constant without dimensions. Now they have given an equation that is C log I over I naught plus 1 equal QV over KP. Now we have to find the dimensions of KT over Q, right? So according to the theoretical things that we learned, we know that a logarithm value is a dimensionless, isn't it? So so this whole term, the dimension, this whole term can be considered as a dimensionless one. And in the question, they mentioned that C is a dimensionless constant, right? So you can able to neglect both of these terms, right? So if there's a dimensionless, I have mentioned that if it is a dimensionless, we represent this by putting 1. So then y1 equal qv over kt. Then if I obtain the asked expression, it should be kt over q equal to 1. So that's mean dimensions of kt over q equal to v. That's mean voltage, right? So in the 24th question, let's move to the 24th question. Consider the following equation, that is y equal a sine w x over v minus k, right? So in this equation, w is the angular velocity, v is the linear velocity. What is the dimensions of k? Right. So now, if you notice this equation very carefully, you should able to identify that this whole term, should be represent an angle, isn't it? Because it is mentioned just behind the sine value, so this could be considered as a angle, right? So if it is an angle, if it is an angle, we know that angle is a dimensionless quantity. Angle is a dimensionless quantity. So the dimensions of w x over p minus k. So dimensions of this whole term should be equal to 1, isn't it? Because angle is a dimensionless quantity. That's the theory, right? So guys, this is the theory. And to obtain the answer for this questions, you have to know another important things, that is dimensions of angular velocity. Guys, these things you will learn in near future, right? But up to now, just remember those stuffs by heart, right? So the dimensions of angular velocity. Dimensions of angular velocity can be represented as t minus 1. So keep in mind that, right? Dimensions of angular velocity equal to t minus 1, right? So let's go for the question. Now, if I expand this equation, I can able to obtain that wx over v minus wk equal to 1. Now, according to the dimensions theory, dimensions of Wx over V equal to dimensions of Wk, and it should be equal to 1 because those are mentioned an angle, right? So, in order to obtain the value for K, let's consider these two, right? So, W represents the angular velocity, isn't it? So, the dimensions of W should be. So, if, first of all, I will subject the K. So, K equal 1 over W. So, K mean K of equal 1 over. If I substitute the dimensions, it should be T minus 1. So, when it's come to the nominator, so the dimension should be K. Dimensions of K should be equal to T. That's the answer, right? Okay, in the 25th question, uh, there's a statement that is U equal Ky over y squared plus x squared, where U is the potential energy, y is the displacement, a is the amplitude. Find the unit and dimensions of K, right? So guys, first of all, let's expand this equation. So what is the method that we need to obtain to expand this equation? Just follow the cross multiplications, right? So if I consider the cross multiplication, then I can able to obtain that U into y squared plus x squared equal to ky. Then uy squared plus ua squared equal to ky. Right. So now the purpose of this equation is to find the dimensions of K. Now y represent the displacement. Right. So both sides we mention the y, isn't it? Y is the displacement, A is the amplitude, right? To obtain the value for A, so let's consider these two terms. Hence, dimensions of uy squared should be equal to dimensions of ky, right? So then uy squared equal ky. So we can able to further simplify this one by cancelling y from each side. Then k equal uy. Now u represent the potential energy. That's why it's energy now. That should the dimension should be ml 2 t minus 2. Now y represent the displacement, so it should be L equal to k. Then dimensions of k should be equal to, this is the correct answer, right? So without having idea of the k, sorry, of the a, you can able to figure out the answer, right? But additionally, keep in mind that amplitude mean it's a kind of a distance, right? Amplitude mean it's a kind of a length, right? So keep in mind that. Right. Let's move on to the other question. 26. In the following equation, here this is the equation f equal a cos bx plus c sin dt, right? So in this equation, f mean force, t mean time, x mean displacement, and find the dimensions of t over b, right? So let's find out this one now. So So dx is behind the cos. That's mean, guys, this should be represent an angle. This should be an angle, isn't it? And also dt product should be also considered as an angle. So the dimensions of bx or bx is a dimensionless quantity, as well as dt, product of dt, is a dimensionless quantity, right? So hence we can able to obtain an answer for now b into x represent the displacement, so it should be L equal to 1. So dimensions of B should be equal to 1 over L, that's mean L minus 1. Let's consider this one. D into T equal 1, that's mean D dimensions of D should be equal to 1 over T, then dimensions of T should be equal to T minus 1. Now you have to obtain the dimension ratio between the D over B. Right. So we have obtained that D is T minus 1 over B mean L minus 1. So when it comes to the denominator, this is the answer. Right. Right. So in the 27th question, a variation of rate of decay of a radioactive sample with time is given by the relationship. This is the equation A equal A naught E minus lambda T. Dimensions of lambda, right? So you know that, guys, this represent the exponential function. Exponential function, right? So exponential function is a dimensionless quantity. So that's mean this lambda t, dimensions of lambda t is a dimensionless, so it should be equal to 1. So t represent the time, so it should be capital T. If I substitute the dimensions, then y lambda equal 1 over t. So the dimensions of lambda should be equal to t minus 1. So this is the answer. Right.